Hello OHBM community. I'm thrilled to have the opportunity to introduce you Physiopy, Open Development Solutions for Physiology in MRI. Briefly, it's a collection of user-friendly toolboxes to collect, analyze, and share physiological data. I have no financial interest or relationship to disclose with regard to the subject matter of this presentation. A little bit background. Why we needed Physiopy? Why do you need Physiopy? As we investigate physiology concurrently with functional magnetic resonance imaging, we are presented with a unique perspective. Natural fluctuations in autonomic physiology, such as breathing and heart rate, offer valuable insights into critical functions like cognition, emotion, and health. However, these physiological signals can also significantly influence fMRI signals. Given this relationship, it becomes crucial for us to study physiology in parallel or effectively account for its influence on fMRI data. While the integration of physiological measures into neuroimaging is still a niche topic, it holds immense potential for advancing our understanding of the brain. Physiopy could help raising awareness about this area and inspire researchers and clinicians to explore the possibilities it offers. To accelerate progress in this field, we must adopt a collaborative approach and share our knowledge, data, and tools. Physiopy is using a community-driven, bits-based open development approach. Community involvement is essential. By engaging researchers, clinicians, and experts, we can collectively shape best practices and drive advancements in the field. The main goal of Physiopy is to facilitate the collection, analysis, and sharing of physiological data. We strive to achieve this goal through various means. First, by developing user-friendly packages to streamline the processing and analysis of physiological signals, making it easier for researchers and clinicians to integrate them into their neuroimaging studies. Also, by specializing in tools and resources that are tailored to address the unique challenges and considerations that arise when working with physiological signals in neuroimaging studies, particularly MRI. By providing documentation that includes tips, strategies, and community practices for collecting physiological data and utilizing our packages effectively. This documentation serves as a valuable resource for researchers and clinicians who are new to incorporating physiological measures into their studies, enabling them to navigate the process with confidence. By helping set a standard for the organization and management of physiological data, providing guidelines and recommendations to ensure compatibility and interoperability. In addition to its primary goals, by engaging with Physiopy, helping develop Physiopy, we learn new topics such as Git, Python, data visualization, and physiology. Summarizing and putting all that together, so these aims distill into 4 core components: a set of user-friendly toolboxes, clear and approachable documentation, a collection of community practices, community of users, developers, and researchers interested in physiology. Now that we understand the motivations and principles behind Physiopy, let's explore its libraries in more detail. Assuming you read our community practices and acquired some physiological data. Is it in bits format? If not, the user have the option to convert the data into bits format. Phys2Bits enables the conversion of various physiological recording formats into bits format. Currently, it supports popular formats such as Acknowledge, LabChart, Spike2, and GE files. Phys2Bits incorporates Bitscoin for a user-friendly graphical user interface. And you don't know how? Don't worry, we got you covered. The documentation is a pillar of Physiopy, as it is meant to guide new users in their journeys with physiological data. We are compiling community practices based on monthly discussions within the community. However, if you do have the data in bits format, or if you would like to skip this step for now, you can do so. Now, let's shift our focus to the other toolbox Physiopy houses, PicDet. PicDet library employs algorithms to automatically identify peaks and troughs in the physiological signals, saving time and effort in the peak detection process. However, peak detection algorithms are not perfect, so the library allows for manual correction of identified peaks, providing users with the flexibility to refine the results based on their expertise and specific requirements. Next up is Fizz2the-Noise. Fizz2the-Noise library designed to create regressors from physiological signal recordings is currently in the alpha stage. The library supports common denoising methods for cardiac and respiratory data. And voila! We obtain analysis-ready physiological signals. Whether you intend to use these signals for denoising purposes or seamlessly incorporate them into your fMRI data analysis. However, that is not all. We are currently compiling a testing dataset by collecting and curating diverse datasets to ensure that Physiopy can handle all types of data effectively. Additionally, we are actively developing the PhysioQC library that will allow you to assess the quality of processing at each step. And for those seeking convenience, semi-automated workflows are in the works. These workflows will enable users to accomplish processing of physiological data with a few lines of code. And with that, I would like to thank you for your attention and thank all Physiopy contributors. Interested in learning more and contributing? Please reach out to us. We invite you all to join the community-driven movement towards a better integration of physiology with MRI. Au revoir!